Transformations, we actually did an assignment, most of you did it, I think, where we took some notes, watched a video of transformations, translations, dilations, and reflections. Nod your head, do you remember that? We didn't do any homework on it. It was just a matter of watching the video and then taking the notes. Okay? That was one of the assignments last week. Because I knew that this is coming, and it doesn't go away. It stays with us. If we have pretty much a whole unit on it, and it can be, I don't know, some students think it can be a little tricky. So we're going to talk about it quite a bit and determine how they impact graphs. In Algebra 2, you use it actually more than we do here in geometry. Okay, so if you look, it says 1.3, representing and describing transformations. So let's start there. There are different types of transformations. All transformation mean is that we are impacting a graph. We're doing something to a graph. If you look at the top of the page, it says a function that changes the position, shape, or size of a figure. Okay? It changes the position, the shape, or size of a figure. Okay, so, for instance, if I have a nice little rectangular square pad, everyone see this pad in front of my nose? I don't make fun of my big nose. Everyone see this pad? Okay, so where it is right now, I can move it 2 inches to your right, my left. I just did. That's called a transformation because I moved its position. That makes sense? Let me go back to the original, back right in front of my nose, and I can rotate it 90 degrees. See me just rotate it? If you can't see it up here, look on the screen because it's there too. Okay, so here, rotate it. I can rotate it 180 degrees. Now it's a square, so it looks like it's the original. Okay, we got it. I can rotate it 360, so it's back to where it started. Those are all transformations. Okay. Now, if I could show it, I would. I'm not sure that I can. Maybe this works. I could multiply this thing by 2, and all of a sudden it becomes this big. See, it just enlarges. That's another transformation. Okay. Another transformation is this. It's here, and it is a mirror image. See how it kind of flipped? That's another transformation. Okay, so we got position, shape, or size. Everyone okay with that? Okay. All right. Shelby, were you able to get in? Just hold on. We'll get it at the end, okay? We'll get it figured out. All right. So now let's talk about more specifically what they're looking at. You have where you start and where you end. They call it a pre-image and an image, but it's where you start and where you end. All right. Okay. So go down to, you can't see it. I'll put it up here as well. Find the unknown coordinates for each transformation and draw the image. Then complete the description of the transformation and compare the image to the pre-image. Okay, so let me show you. So you guys can see it on the screen. You got 1, 1, and so can you guys see that all right? It's not great, I know. But there's a little better. All right, so find the unknown coordinates for each transformation and draw the image. Then complete the description of the transformation and compare the image to the pre-image. All right, so back to here. That means we've got, it said this, x, y, and then that arrow means maps to x minus 4 and y minus 3. So that's the transformation. And you heard me use a phrase, maps to, that we will use a lot. Transformation and maps to. All right, now if you look at the picture, they've got an original triangle that is I don't need the whole graph. So where's point A? Looks like that's at what, 0, 4? 1, 2, 3, 4. There's point A. Point B looks like it's at 1, 2, 3. 1, 2, 3. And then C is at 0. And so we got this triangle. Okay, so A is at 0, 4. You can just write the triangle freehand if you are trying to there. You don't need graph paper. Okay, so all right, that looks all right. So now what we're going to do is there's 3 points there, and we're going to use the rule or the mapping, the transformation, to kind of move the graph. That's a triangle, and we're going to move it. We're going to translate it. Okay? So let me come back to my working paper. So we've got 3 points. We've got point A, which is at 0, 4. So write that down. Then we've got point B, which is at 3, 0. And then we've got point C, which is at 0, 0. Everyone okay so far? Just copy the points. All right. Hey, Waymaker, can you shut the door for me, please? I like Mr. Richmond, but I don't want to distract you guys. All right, so first rule, notice I use an arrow because that means maps to or a transformation. Okay. I just apply the rule. Let me highlight the rule. What are we going to do to the x? We're going to subtract 4. What are we going to do to the y? We're going to subtract 3. So we're going to take each term of the a coordinates, 0. Is this the x or the y? Very good, Naomi. Remember, it's always an xy ordered pair. If you don't remember that from algebra, that is the xy coordinate plane, and it's always in alphabetical order. Okay, the x always goes first, and then the y. X-axis, y-axis. Okay? All right, so the x is first, and what are we doing? We are subtracting 4. So we're going to go 0 minus 4. And on the y, that has a value of 4. So we're going to go 4, but we're going to apply the rule. We're going to go 4 minus 3. All right, let me pause there. All right, Riley. It says y minus 3, and then I put 4 minus 3. What did I do? Take a wild guess. Any idea? All right, all I did was, you see that has a value, that's a letter y, what I'm pointing at right there? And then what coordinate is the 4? Is it the x or the y? So all I did is I took this y and I plugged it in for that y. Which in Algebra 1, you guys know what that's called? Substitution. Remember that? Okay, so really all I've done, I'm going to stand up here and show you, so sorry those of you watching the recording. But all I've done is done a big substitution. I've taken the coordinate 0 and 4, and put 0 in for x, and I put 4 in for y. That's simple. Now I'm going to get a result. Okay? What is 0 minus 4? Negative 4. What is 4 minus 3? That is negative 4, positive 1. Now, you need to name this point. It's not A anymore because A was at 0, 4. So we have a different name that we give to it. It's called A prime. A with a dash, an apostrophe, something. A prime. It's a notation. Okay? It's called A prime. All right, let's take care of B and C before we graph. All right, so B is going to be, the x value is 3 minus 4, and the y value is 0 minus 3. So B prime is going to be negative 1, negative 3. Let me pause there. Rebecca Brown, do you get that? You understand it? Shelby, do you get it? All we're doing is substituting x in for x and y in for y. Sears, you got it? Okay. All right, let's do C. Coffee, why don't you do C for me? Put 0 in for x and 0 in for y. What would we get?
0 minus 4.
Good. Follow the pattern. Very good.
0 minus 3.
Very good. 0 minus 4 and 0 minus 3.
Negative 4, negative 3.
Good. So C prime, thank you, would be negative 4, negative 3. If you guys do the transformations like this, it is a piece of cake. If you try and do everything pictured in your head, it gets all convoluted. So follow the pattern. I'll teach you the pattern, and you'll get it right every time. Okay? Every time. All right, so now what we want to do is graph. Because we have 3 new coordinates. We have A prime, B prime, and C prime. I like graphing. You know, so here we go. What's the coordinate of A prime? All right, so negative 4, 1, 2, 3, and 4, and positive 1. So there's A prime. And you can just do this freehand if you don't have the book with you or whatever. And what's the coordinate of B prime? Negative 1, negative 3. Negative 1, 1, 2, 3. There's B prime. And C prime is negative 4, negative 3. I'm going to connect those. I'm not going to use a straight edge. Just keep it as straight as possible. Can everyone see how this moved to the left 4 units and down 3 units? Deacon, you got it? Can you see it? Okay. Into? All right. Pretty easy. No, I don't think that's too difficult. All right, so the book then asks the question, the transformation is a translation 4 units left, which we already said, and 3 units down, which we already said. Okay. Same size, same shape. All right, let's move on. Let's go to letter B. If you don't have it, just relax. I'm going to copy down the main points. All right, so example B. It says xy to negative xy. Ooh, throwing a curveball at us. The old curveball. So that's the transformation they want us to look at. And then they've got a graph over on the right side. So let me, I'll get a sheet of paper. The original picture is in bold. Waymaker, do you see the original picture over there? The original graph? Do you see the original graph? Yeah. Waymaker? Okay, what are the coordinates of the original triangle? We'll look at example B. I think it's at the top of the next page. Seriously? Oh. I'll come down after school.
T is -4, +1.
Hold on, you're going too fast. -4, +1?
Yeah.
1, 2, 3, 4, +1. She said that was T. Good.
And S is -1, +3.
Okay, S, -1, +3. Keep going.
R is -4, +3.
There's R. Okay, so we've got a right triangle, it looks like. Right there, is that right, Waymaker? All right, so there's the triangle. So now let's go ahead and apply the transformation. Step by step, and it's a piece of cake. Don't get ahead of yourself. All right, so she already told me these, but I'm going to go through them again. Well, let's not call it A. Let's call it the letters that they have. So let's go T. And the coordinate was what? -4, +1, Waymaker?
Yeah.
R, -4, +3, Waymaker? You gotta be confident. You want me to look at it? Make sure. 1, 2, 3, 1, 2, 3. Yeah, you're right. And then S was -1, +3. Okay, everyone good so far? But basically, just copy down the problem so far. All right, so now we're going to apply the transformation. The transformation in this case is -xy. Okay, so if I apply that, what's the negative out in front? What's that mean, Sears? What's this negative mean? Yeah. It is. You take the opposite sign, or another way to say it is you multiply by -1. Okay? I know it seems real simple. You just take the negative of it, but if it's a negative of a negative, then it becomes positive. So a good way to think of it mathematically is you multiply it by -1. Okay? All right, so if I take this, multiply -4 by -1, I get a +4. And if I take y and I just put in 1, and so T prime is going to be +4, +1. Okay, next one, same thing, -4, and 3. R prime is going to be +4 and 3. Am I going too fast? No, we're good? Okay, next one would be -1 and 3. Nothing's happening to the y's. They're staying the same, aren't they? And then S prime would be +1, +3. Let's graph our new triangle. Riley, you good? Got it? Okay. Coffee? All right. All right, so T is 4, 1, 1, 2, 3, 4 there. That's T prime. R prime is 4, 3, which would be here. And then S prime would be 1, 3, which would be here. How would you describe what happened to this graph? You want to try it, Cantu? Mirrored, good. Or you could say it flipped. But I like a mirror image. That's a good way to say it. It went from one side to the other. Okay, got it? Sears, you good? Naomi? Make sure we answered everything. Transformation, oh, there's a good word. They use the word reflection. I'm going to write that word down because that's important. It was a reflection. It flipped, or you guys use the word mirror image. All of those are true, and all of those work as a description. Okay? All right, we good? Okay, let's set up letter C. Let's do this. If you've got the book, you can go ahead and try and complete letter C together, by yourself, I mean. If you don't, stay with me. I'm going to set up letter C, and we're going to start going through it. We won't complete it until everybody's done. Got it? But if you got the book, I want you to try and do letter C by yourself.
In the book or in the notebook?
You can do it in your book. You can just do it right in your book if you've got the book. Okay? If you have it online, you have to do it on a piece of paper. If you don't have the book, I think Miss Shelby, we're going to set it up here. Okay? All right, here we go. Shelby, I got a new sheet of paper. Way big. Okay. Shelby, what it says is we go from XY, here's the transformation, XY to 2XY. All we're doing is multiplying the X coordinate by 2. Okay? And the original graph has J, K, and L. J looks like it's at negative 1, 2. K looks like it's at 2, 2. And L looks like it's at 2, 1, 2, negative 4. Got it? All right, so we're going to rewrite those in order. We got J, K, and L. If you're going to be talking, put your masks on. J, negative 1, 2. K is 2, 2. And then L is 2, negative 4. Now, all those just come straight from the graph. So you just have to look at the graph paper. Okay, so they're not given to you. You don't have to generate them in any other way. Okay? Good? All right. I'm going to pause there for everybody else. You can go ahead and go from there. Apply the rule and let it go. Offenbarger, what time we get out of this class? I would think you would know that. Coffee? 9:20? Lily, what time? 9:20? I'm asking Lily from now on. I'm not asking Offenbarger. Ezra, did you know? Deacon, did you know? Lily's the one we're going to. Waymaker, did you know? What time we get out of class? You did? All right, Lily or Waymaker? You done, Juanita? You got it done already? Oh. Not confidently, though, huh? You get it? Oh, think you got it? Shields, you wish you had all these color markers, don't you? Tears. I know, it's tears. Don't you wish? No? Okay. That's enough time for you to struggle through and see if you got it done. Let's apply the rule. We multiply by 2. And so 2 times negative 1 is negative 2. The y stays the same. That makes it simple. Multiply 2 times 2. We get 4, 2. And then we get 4, negative 4. Well, in this case, there's really not much to do. We're going to get the exact same thing. We have J prime is negative 2, 2. K prime is 4, 2. And L prime is 4, negative 4. Now, the only thing that you could have shown here is 2 times negative 1. See how you multiply that out? Just a simple, just a step between. And then this would be 2 times 2, and this would be 2 times 2. All right, so let's graph it. J prime is negative 2, 2, negative 2, positive 2. Is that showing up on the graph? Yeah, not too bad. And then K prime is 4, 2, 1, 2, 3, 4. And then L prime is 4, negative 4. All right, how would you describe, Lily, you want to take a shot at this? How would you describe the transformation? It was, not bad. Waymaker, how about you? How would you describe it? Okay, so look below in the book. It says the transformation is a blank, horizontal, vertical. You have that choice. Stretch by a factor of. All right, let's answer that. Okay, so look at the original graph and then look at the one in orange. Do you think it stretched this way or do you think it stretched this way? So you think it went that way? Up and down? That's okay. That's all right. It happens. All right, let's make sure we have it right. You guys know what horizontal is?
Yes.
And we got vertical. Okay. So if I look at this picture, JK is only 3 units across. Not just for Waymaker, but I like picking on her. Okay? So it's 3 units across, right, Waymaker? Okay, but if I go from J prime to K prime, how far is it across there? 6 units. Do you see how that stretches out? And that's a horizontal stretch. Okay? So in your book, you would say that this is a horizontal stretch. It's not vertical, though. And here's how I know it's not vertical. Because the distance between K and L in the original is 1, 2, 3, 4, 5, 6. And that's also the distance on our new image. That make sense?
Yeah.
So it didn't stretch vertically, it only stretched horizontally. Okay? And so, this is a horizontal stretch. Now it says also by a factor. How much wider is it? 2. By a factor of 2. Which that should make sense because what did we multiply the x-coordinate by? 2. Makes it really simple. You just have to look at what the transformation is and it's right there. It tells you by what factor it's being stretched or shrunk. Because actually we could go the other way. If it's greater than 1, listen to this little nugget. If it's greater than 1, it stretches it. If it's less than 1, it shrinks it. Let me say that again. If it's greater than 1, it stretches it. If it's less than 1, so we multiply by 1/2, it condenses it. It shrinks it. You're going to have some of those on the homework. All right, questions so far? Good. All right, let's go to the top of the next page, which is page 33. It says describing rigid motions using coordinate notation. All right, so this is what we're talking about a rigid motion, that it preserves all kinds of different things. Here's the definitions. It says rigid motions preserve distance. Rigid motions preserve angle measure. In other words, the shape, remember how I was doing this? Those were all rigid motions. They're just changing, but the position, I mean the shape of it stays the same. It's still a square. It preserves betweenness, collinearity, which means things that are in line are still in line, and things that are parallel, like these two things would be parallel, would still be parallel. Okay, so go down to example 1. It says use coordinate notation to write the rule that maps each pre-image to its image. All right, so basically what they're saying is they want us to go the other way. So before, we had the rule. They were giving us the rule. This is the rule, or we were calling it the transformation. So in this example, the next example, we're going to have to find the rule. So they do the transformation, and we've got to figure out, okay, how did that move? How is it? How is the rule? This is challenging, but it's good. All right, we're going to pause there. We'll stop for the day. No homework for tomorrow.